You are welcome to GMAETS 41's physics class. In our class today, we are going to give attention to how to multiply vectors. We'll be looking at one of the methods of this algebra of vectors, vector multiplication. Recall that in our previous class, I already taught you the first part of algebra of vectors, which has to do with addition and subtraction of vectors. So when you are given vectors and you are asked to multiply, what do you do? This class is going to cover part 1 of multiplication of vectors. So once again, welcome to this class. Once you join this class right away, share the link to your friends, okay? Share the link to your friends. Invite them to also connect so they can learn, especially to our friends, who already have been admitted into 100 level. Those in 100 level, the students that offer further mathematics also, because this part of physics is also encountered in further maths. When you are given vectors to multiply, there are two approaches that can be used. Now, depending on the problem given to you, that will determine the method of multiplication to use. This class will focus on dot product method. Dot product method of multiplying vectors is also known as scalar multiplication of vectors. And someone might wonder, why do we actually apply scalar multiplication? Why do we do dot product of vectors? The reason is simple: so as to get a scalar. You carry out dot product so as to get what? A scalar. And then when you are given a particular problem where you are to multiply, and you are carrying out cross product, which is also known as vector product. There is a reason you're doing that. If you carry out cross product of two vectors, your aim is to determine another vector. Like I said, we are focusing on dot or scalar product multiplication of vectors. On this channel, in our playlist already, we have a video lesson pre-recorded in Physics 101 playlist that deals with, the dot or scalar product fully. We just want to extract a part and deal with it in our live class. So first, it's important for you to know what dot product is all about. What is dot product of vectors? When you are given two vectors to find a dot product, what is it all about? Let me assume that I have these two vectors, vector A and then vector B. Now these two vectors, they meet at a certain angle. You are asked to find the dot product of A and B, which we write as A dot B. It's also the same as B dot A. All right, because the rotation of this angle can either go upward or downward. Either way you rotate the angle is still okay and allowed for dot multiplication of vectors, because dot multiplication is commutative. When we say that dot multiplication is commutative, what do we mean? The order of arrangement of multiplying the vectors does not matter. If you do A dot B, you still get the same result as B dot A. So to obtain the dot product of two vectors, it's important for you to know mathematically that A dot B, which is also the same as B dot A, because I told you that vector multiplication in terms of dot product is commutative. The order of handling it does not matter. Now, the dot product of two vectors, say A and B, is equal to the product of their magnitude. The product of their what? Magnitude, which means you have vector A and vector B, you find their magnitude. Then go ahead and multiply by the cosine of the angle between them. Multiply by what? The cosine of the angle between them. This is the definition of dot product of two vectors. The dot product of two vectors is defined as the product of the magnitude of the vectors and the cosine of the angle between them. When you take the dot product of two vectors, your final result is a scalar. You want to take note of that. Your final result is what? A scalar. Which means this whole thing you're seeing here, this guy, magnitude of A times magnitude of B cos theta, we produce a scalar for you. We produce what? A scalar. So you want to take note of that. You know, in part 1 of the algebra of vectors, where I taught you addition and subtraction of vectors, if you add and subtract two or more vectors, the final result is going to be a vector. If you are multiplying vectors, and then the method of multiplication is scalar products, also known as dot products, your final result is going to be a scalar, that is a number. So you want to take note of this. When do you use this formula to obtain the dot product of two vectors? When do you use this formula? You apply this formula if the angle between the two vectors is given to you. I repeat, this formula, let me call it equation 1, is applied when the angle theta between the two vectors is what? Given to you. Is that clear? So if you don't know the angle between the two vectors, using this formula, I don't know what you're going to get. You won't get anything. You can't arrive at any result. So you apply this definition of dot product of two vectors when the angles between the two vectors is given to you. And perhaps you know the magnitude of the vectors, or you can get the magnitude of the vectors, or you can get the magnitude of the two vectors. But significantly, you see the angle between them, it ought to be given to you. That is only when you can use this formula. To calculate the magnitude of vectors, I already taught that in our previous class. You can check through the video lesson on this channel, either the playlists. There's a special playlist dedicated to, the concept of scalars and vectors, or you go through the live session of this channel and you see the video lesson covering that. Now, sometimes an examiner can give you a problem where it requires you to carry out dot product, scalar product of these two vectors. However, you might not be given this angle. You might not. In that case, the components of the vectors are being given to you. The components of the vectors are being given to you. So apart from this definition that the dot product of two vectors is given as the product of the magnitude of the vectors. Product means the multiplication. The multiplication of the magnitude of the vectors and the cosine of the angle between them. Apart from that definition, if the components of the vectors, right? If the components of the vectors are given to you and the angle between the vectors is not given, I take that again. A problem is given to you, you know the components of the vectors. You know the components of the vectors. But the angle between the two vectors is not given. In that case, you can't use this formula because, like I said, you use this formula when you know theta, the angle between them. But in this case now, the components of the vectors are just given to you, and the angle between them is not given, it's not known. This is the definition of dot product you are meant to apply. If vector A is equal to AXI plus AYJ, let's say plus AZK, vectors in 3 dimensions. A vector in 3 dimensions. So you can see the x component, the y component, and the z component with our unit vectors or direction vectors I, j, and k. And again, vector b, the component is given to you as bxi plus byj plus bzk with their respective direction vectors ijk. So you see, in this problem, right, the scalar components of the vectors are given: ax, ay, az, bx, by, bz. I give you these vectors. You know, these vectors are known as position vectors or displacement vector, right? Position vector or displacement vector. I've talked about that, and I believe you friends have learned it from our previous class. So if the position or displacement vectors are given to you in component form, as you can see, but the angle between them is not given, how can you get the dot product? It implies that A dot B. In this case, what you have to do is apply a knowledge of like-term approach in a multiplication. You come to this guy that has this direction vector I, this one that has this direction vector I, multiply their components. So it's going to be ax times bx. So this is going to be equal to a subscript x times bx, which of course is ax bx. This component, this scalar component of these vectors you are seeing, ax, ay, az, bx, by, bz, they are numbers. They are numbers. They are the scalar component of these vectors, right? I hope I'm communicating. These are numbers. They are the scalar parts. Every vector has a scalar in it because a vector has direction. All right, so let's go, please. So those scalar components, multiply them like term to like term. So ax bx plus, you come to this component with the direction vector j, you know, the y component. So it's going to be ay by plus finally az bz. So this is the formula you're going to use. And of course, you're still going to get a scalar. This quantity you're seeing here is a scalar. Is a scalar. We're going to call that equation 2. This quantity you're seeing is a scalar quantity. Is a scalar quantity. I hope this has not cut off anyway. Let's call this equation 2. Let me check the camera and be sure that that part is not cut off. Emmanuel Silvetor, how are you? Welcome to join this class. You're welcome to join this class. Raj, how are you? It's okay, let's continue. Today is actually a brief class. Home of slaughter. How are you doing? Let's continue, please. Once you join the class, like this live class, share the link to your friends, okay? Share the link to this live class to your friends and invite them to join. We just have about 30 minutes to work on this. All right, so I have been able to give you the 2 formulas you need when you are talking about dot product of vectors, scalar product of vectors, right? The result you're going to get, like I said, is going to be scalars. Take note, I'm emphasizing on this because if the method of multiplication of vectors you're dealing with is cross product, which is vector product, your final answer, your result will not be a scalar, will not. These ones for scalar products, for dot product, you're going to get a scalar. As a matter of fact, why do we actually carry out dot product of vectors? All right, we do this to be able to get scalar quantities. That is why if there is any scalar quantity that can be calculated from vectors. Example, work. Don't worry, we're going to solve question on it. Work can be obtained from vectors, force vector and position vector. Force vector and position vector. Because you know that work is equal to force times displacement. That position vector acts as a displacement there. Since force times displacement will give you work, and work is a scalar, It means if you are solving that problem for the first vector and position vector, you are meant to do dot product, since the final result you are going to get is a scalar. So you see any quantity that is a scalar, you can get it from vectors. You do dot product to obtain that result. Now, these two quantities are equal because both of them are defining dot product, dot product. So what is the implication? Now note, equation 1 and 2 are the same. Equation 1 and 2 are the same. Because they are the same, let me show you something. If I equate this to this, let me give it to you as a note. You know, I'm just trying to summarize this. Like I said, you can still get a full video lecture on this channel. Go to physics playlist, okay? Physics 101 playlist. This is A dot B. This is A dot B. And this A dot B, in terms of angle, is equal to this formula, right? This A dot B is equal to this formula. Both of them are defining A dot B. So if the left-hand side, right, are equal, it means that the right-hand side must also be equal. So we can equate these to this. We can make both of them equal. Are you following, right? This to be equal to this. And watch, because I want to do this thing once and for all without wasting time. If magnitude of A times magnitude of B cos theta is equal to AX BX plus AY BY plus AZ BZ. If we equate both of them, you can make this theta subject to the formula, this angle. You can make this angle subject to the formula. Because sometimes you can be asked to calculate the angle between two vectors. Dot product can help you out. Cross product can also help you. But let me tell you, if you have the choice of using dot product and cross product, dot product is best to use. So all you have to do is to make this theta subject to the formula. So note, theta will be equal to, you know, if you equate this to this, and you are making theta subject of the formula, it is going to be cos inverse of this quantity, which is AX BX plus AY BY plus AZ BZ. And don't forget that this is A dot B. This quantity you see here is equal to A dot B. Then divide it by the magnitude of the two vectors, magnitude of this times magnitude of the second vector B. So you want to take note of this formula also, equation 3. This is used to get the angle between the two vectors. The angle between the two vectors, which is classically the direction of the vectors, right? The direction of the vectors. You use this formula to calculate it. Remember that the numerator is still defining dot product A dot B. So if an examiner already gives you in the problem, you are giving the value of the dot product A dot B, that's what you fix here. But if you're not given the value, let us assume that the component of the vectors are given like this. I want to calculate the angle between them, between the two vectors. You must do the dot product yourself. You must do this yourself. That's why I showed it here. Then divide by the magnitude, the product of the magnitude of the vectors. So when dealing with vector or vector multiplication in terms of scalar product, this is actually a unique introduction to it. Basic calculations on this concept are usually drawn from these three formulas you have there on the board. Now let me give you these notes. I'm going to write this here, notes. When two vectors are orthogonal, when two vectors are what? Orthogonal. That is, two vectors that meet at 90 degrees. When two vectors meet at 90 degrees, their dot product is equal to 0. Their dot product is equal to what? 0. The reason is because for orthogonal vectors, vectors that are perpendicular, vectors that meet at right angle, vectors that the angle between them is 90 degrees. If you come here, you fix cos 90. Cos 90 is 0. Cos 90 is 0. This happens when the vectors are perpendicular, when they meet at right angle, when they meet at 90 degrees. The angle between them is 90. That is also the same as orthogonal vectors. For orthogonal, so if you hear this, for orthogonal vectors, theta is equal to 90 degrees. You want to take note of that because they meet at right angle. So the implication for that is that the dot product of the vectors, A dot B, for example, if I assume that these are the two vectors and they meet at 90 degrees, this angle is 90. In that case, you see something like this. Vector A, vector B, then this is 90 degrees as theta. So this is going to be equal to 0. This is equal to 0 because cos 90 will give you 0. 0 times this product will still give you 0. So don't forget this. In fact, I'm going to call this equation 4. Yes, it's an equation that you need to know. Because we are saying that dot product is not equal to 0 under this condition of orthogonality. So whether you do this, you will get 0. Or you do this. Or you do this. You carry out this product. You still get what? 0. You still get 0. So you take note of that. I think I am done with the basic things you need to know about dot multiplication of vectors. If you have any question, you can drop it in the comment section. At the end of this live class, a copy of this live class will be made available. And for more information, reach out for the full video lecture on scalars and vectors. It's here on this channel. Go to Physics 101 playlist and you will see the video lesson to take. At this point, we're going to solve just a few questions. All right, we're going to solve a few questions using what we have established. Home of Slaughter, I thought you said magnitude of A and B is equal to AX BX plus AY BY plus. Then why do you now equate it to magnitude of A times magnitude of B? All right, thank you for the question you asked. Thank you for the question you asked. However, I did not say that magnitude of A times, oh no, I did not say that magnitude of A and magnitude of B is equal to that value that you quoted, okay? I didn't say that. Take note of what I said on the board. This is not magnitude. This is not magnitude. This is vector A dot vector B. It's not the magnitude of the vectors. It's not. Take note of that. The question you asked, you suggested that I said, which was not what I said. I didn't write that on the board. You said that I mentioned the magnitude of A and B. This is what you said. And B is equal to AX BX plus AY BY plus AZ BZ. No, I did not say this. It is not the magnitude that is equal to this. It is not. What is equal to this multiplication you're saying here is A dot B without their magnitude. Without their magnitude. Even here where you saw magnitude, it is still A dot B that is equal to the multiplication of their magnitude times the cosine of the angle between them. So, Home of Slaughter, as the name I saw there, I hope I've been able to correct your thoughts. I hope I've been able to correct your thoughts. Okay, so I'm going to wipe this board. I'm going to wipe it. Like I said, can still come back later to take the video lesson and copy the notes if need be. Please, let's solve some questions. We'll have just a few minutes to round off, okay? Let's solve some questions, and I'm going to be pretty fast in solving the questions. I'm going to be fast. I've given you all the necessary formulas you need when dealing with scalars, scalar multiplication or dot multiplication of vectors. They are simple concepts. For further information, for step-by-step classical analysis, if you do have any, all right, please take the full pre-recorded video lesson where all these concepts are being analyzed. And of course, don't just stop here. Go further, because you need to know the properties of scalar or dot multiplication of vectors. You need to know the properties. For example, the note I gave here for orthogonal vectors, that their dot product is equal to 0. It is from the properties of scalar product, of dot product. Okay? So don't stop here. Don't stop here. This is just a highlight to, awaken your friend's spirit. You need to wake up. School has resumed. Am I communicating? School has what? Resumed. So I've got this question. I'd like us to solve. Let's see what we have there. Question 1. The force moving a car. The force moving a car is given as F equal to 2I plus 5J minus K if the car moves with a velocity, moves with a velocity of I plus J plus 2K, find the power developed in the engine. Find the power developed in the engine. Find the power developed in the engine. Good. So this is our first question. The force moving a car is given as this. If the car moves with a velocity of, you're given this as the velocity, find the power developed in the engine. Please. We're taking the unit of the force is Newton. All right, sorry, I didn't write it. And the velocity is meter per second. The velocity was given the unit of meter per second. So their units were given. Now, let us solve this problem and see how fast we can obtain it. Now, if you look at this question, we are given the force vector. The force vector is 2I plus 5J minus K. We're given the velocity vector. The velocity vector is I. Let me fix the units in Newton. The velocity vector was given to be equal to I plus J plus 2K in the unit meter per second. We do not know the power developed in the engine of the vehicle, of the car. We are asked to find the power developed. Dear students, are you aware of this formula? That power is equal to force times velocity. Power is equal to force times what? Velocity. You obtain this formula from power equal to work over time, because we know that power is the rate at which work is done or energy is expended. And if power is work over time, work is force times displacement. So you now have power to be equal to force times displacement divided by time. Displacement over time from motion parameter is equal to velocity. So if power now is force times displacement over time, remove it and replace it with velocity, power will now be equal to force times velocity. Now the question now is, if power is equal to force times velocity, this multiplication is going to be which multiplication? Which multiplication are we going to do here? Because if you look at the parameters given, the force is given to us in vector form. The velocity is given to us in vector form. Am I communicating? So, which multiplication would you do to relate these two vectors given? The answer lies on what this quantity power is. Is power a vector quantity or a scalar quantity? Because once you know what this quantity is, you will know the multiplication to do here. And I'm going to tell you for free, okay? Although we've treated that in our past class. Power is a scalar quantity. It is not vector. Take note. Power is scalar. So since we are to calculate power from force and velocity vector, and power is scalar, To multiply these vectors, we are going to use dot product or scalar product. Dot product is also called scalar product. So we're going to say that, but we know that power is equal to F dot V. That's the formula. The force vector times the velocity vector. So power is equal to 2I plus 5J minus K. And then we are taking its dot product, multiplication with I plus J plus 2K. I already gave you the formula of handling this. When components of vectors are given to you and you are asked to find their dot product, equation 2, do you remember? You take the multiplication of like term components. The x component, you multiply them. The y component, you multiply the z component. You multiply them and then sum everything together. So here, this is the x component 2. You can see the scalar component of this vector part here is 2. The scalar component of this vector part here is 5. Scalar component of this vector part here is minus 1. Here, plus 1, and plus what? 2. The coefficient of the direction vectors ijk, their coefficient. So this is going to be p equal to 2 times 1 plus 5 times 1 plus minus 1 times 2. You see what I did here? I just extracted the coefficient of the direction vectors ijk, respecting the like terms, I to I, their coefficient, pick it out and then multiply. JJ, their coefficient, pick them, multiply them. KK, their coefficient, pick them, multiply them, and then add. So you see that this calculation is 1 plus 1. You can do it. It's really far below you. You are ahead of it. Yes. So let's move on. All you now have to do is to simplify this using your basic mathematics knowledge. This is 2, this is 5, this is minus 2. So let me just show it. 2 plus 5 and then minus 2. Therefore, the power developed in the engine of the vehicle is equal to 5 watts. Is equal to what? 5 watts. So this is how simple we calculate power developed, right, in the engine of a vehicle or engine of any, engineering device. The power developed if the force and velocity vectors are given. This is just how you play with it. And I know that you understand it already. Nothing is there. The challenge was just to remember the formula. And I've shown you, most of you are aware, you know that power is work over time, energy over time. You should also be aware that power is force times velocity as well too, right? You see this value 5, supposedly you can still get it if you decide to get the magnitude of this, and multiply them. Perhaps further, I don't know. Maybe you can try that. I told you to get the magnitude of vectors, you use Pythagoras theorem. So how about somebody do it and then drop your comment in the comment section much later. Find the magnitude of this, which is 2 square plus 5 square plus 1 square. If you add them, take the square root. 2 square is going to be 4. This is 25. 4 25 will give you 29. Right? Then multiply by these. Find the square root. Come here, do same. Find the square. Then multiply both of them directly. Because in that case, if you find the magnitude of this, you've gotten a scalar value. Magnitude of this, you've gotten a scalar value. Then multiply them. Anyway, that's not what I'm teaching you. Just say you should verify. We are done with this question. I'm going to wipe it, so we'll pick another question, okay? I'm going to wipe it, so we'll pick another question. So you see, we used equation 2 to solve this problem, to get the scalar product, because the angle between these two vectors was not given. If the angle was to be given, right? If the angle were to be given, were to, because it was not. If the angle were to be given, of course, we wouldn't be doing this. You would use equation 1 in that case. Finish up. Let me wipe and then we'll take question number 2. Royal Chukuka, good evening. How are you? Welcome to join this class. I love what you're doing. Thank you so much. I appreciate your commendation. Thank you for joining the class also. Please, let's wipe this. If you are in 100 level per se, in 200 level, sciences, engineering, medical field, you know, where in the university setting, when you talk about medical field, there are various departments there. Medicine and surgery is there, radiography, anatomy, physiology, nursing, mention them, environmental health science. There are many of them. Then you talk about sciences. There you have bioscience, to include biochemistry, to include microbiology, to include industrial chemistry, industrial physics, mathematics department, environmental sciences. You talk about agriculture. There are many of them. Engineering, you talk about chemical engineering, civil engineering, mechanical engineering, material and metallurgical engineering. You talk about polymer and textile engineering. We have information tech and many of them. You all are going to offer this course in your 100 level first semester. So why wait? Most of you are processing your admission now, and you have this opportunity to be learning from home. Whether you like it or not, lecture has begun. Lecture has begun. No school is going to wait for you that you are processing your admission. Once the academic calendar has stated that we are meant to start lectures also time, lecture will kick off. So when you miss your lectures, GMAETS 41 is a platform that is here to help you cover up. And every single thing in your core courses you need, I take them on this channel. In fact, there are video lessons. The video works are already available completely on this channel. Make use of it. Make use of this channel. You can become a channel member, right? You can also register for GMAETS 41's tutorial. If you are a Unizik student, you can register for GMAETS 41's physical tutorial on campus. I'll be kicking off my physical tutorial on Unizik campus this week, right? On Tuesday, to be specific, I'll kick off. You may not be seeing me every day running around with you to come and advertise. I might advertise once a while like that, maybe once a week and so. You know about GMAETS already. This is the home where first-class students are being made. The records are there. Join us. Question number 2. Two vectors. Two vectors on a P. P equal to 3i minus 2j plus k. And Q equal to I plus 2j plus 3k. Have an angle of 60 degrees between them. Calculate P dot Q. Calculate P dot Q. So let us see how we play around this problem. Now, if you look at this question, you agree with me that the position vectors, the displacement vectors have been given to you. You can see in their component form, C, right? And then we are told the angle between them is 60 degrees. Calculate P dot Q. So how do we compute Q or P dot Q or Q dot P? Because we're still going to get the same thing. Without wasting time, let us recall that P dot Q is equal to the magnitude of P times magnitude of Q, and then multiply by the cosine of the angle between them. You know why I am using this formula this time around, right? We are using this formula because the angle between the two vectors was given. The angle between the two vectors was given. We are asked to compute P dot Q. Although we could go straight and do P dot Q straight on. 3 times 1 plus minus 2 times 2 plus 1 times 3. We could do this, right? I'm the one that just decided to give this angle here. I'm the one that decided to give this angle here. Yes, because I want us to solve a problem where the angle is given from the source question. From the source question, we're just given P and Q, and we're asked to compute P dot Q. I decided to add an angle because you have to understand how these formulas that we've established this evening, how they are used. So let us do this. Even if you could have done this dot this, like I said, that is 3 times 1 plus minus 2 times 2 plus 1 times 3. Then sum them together and get your answer. I chose to go through this way where I would make use of the angle. Like I said, I was the one that created this angle. Please take notes. I'm emphasizing on this that I created this angle in case you do this dot this separately. Let's assume you multiply this by this separately to get the answer using equation 2. And then you decide to also solve what I'm trying to solve here using the angle, equation 1. And you find out that both of them are not the same. Please, don't hold me accountable. Don't. I didn't sit down to think of the angle that will be between these two vectors, such that if you do this dot this straight, the result you will get will still be the same as using this formula. It's meant to have been tested, as the case might be. Does that make sense? If I had processed this question before, including that angle, because like I said, from the source question, they only gave us this and this without this angle. If I had processed it, what the angle should be, what the angle between these guys should be, if I processed it, it's possible that it might not be 60. For example, if I didn't give you this angle, and I decide to say, okay, find the angle between these two vectors, I may solve and not get 60 degrees. I may solve and not get 60 degrees. Or should I just even reevaluate this question? Let it be that we are looking for the angle. I think I should do that. I have a reason for what I'm trying to do. Okay, let's assume that we should calculate the angle between them. Let's calculate the angle between them. You've seen that I wrote 60. But I'd like us to solve this thing and see if truly the angle between them is 60. For you to understand what I'm trying to say, that I created this angle without processing this question. It's possible that the angle between them is not 60. It's possible. So I may have used the wrong angle because I did not process this question. So for that reason, please, we won't even compute P dot Q. Already we've done that. So let me rephrase this question. Two vectors, P equal to this and Q equal to this, have an angle of dash between them. So I think let's go this way and see what we're going to get between them. Good. So we are looking for the angle between the two vectors. Of course, you have to use this formula because this is the formula that contains the angle. And since you are looking for the angle between them, your theta will now be equal to the dot product of these two vectors. Just make theta subject to the formula. It's going to be the dot product between these two vectors, then divided by, cos inverse first. It's going to be equal to cos inverse of the dot product between the two vectors divided by the magnitude, the product of the magnitude of the two vectors. You have the formula already, so this is what you're going to get. Now, P dot Q, remember, is dot product. Here, we are given the component form of these vectors. We are given the component form of these vectors. So from the component, we can get P dot Q. Simply AX, BX, AY, BY, AZ, BZ, then you add them together. Also, we can get their magnitudes because we know the value of the component of the vectors. We can determine their magnitude. So let us do that and see. From here, I would say that P dot Q is equal to, let's take the product now, like I explained earlier, the II. We don't have time, let's go straight. 3 times 1 will give us 3 plus minus 2 times 2 will give us minus 4. Minus 2 times 2 will give us what? Minus 4. So if I'm doing this plus, it's going to be open bracket minus 4. A waste of time. Plus times minus is already minus. So I could have just fixed minus 4. Then 1 times 3. 1 times 3 will give us 3. So this is equal to 3 plus 3 is 6. 6 minus 4 will give us what? 2. So P dot Q, the dot product of these two vectors is 2. Let's proceed and obtain their magnitude. Also, magnitude of vector P is equal to square root. We've treated this concept in our last class. Please, we have a timetable guiding our online classes: Mondays, Wednesdays, Fridays. Mondays, maths. Wednesdays, chemistry. And then Fridays, physics. This class, I'm holding it today, because I just wish to hold it. Usually, I don't come on live on Sundays for you friends. I don't. But I just decided to do that because for like a week now, I've not really met you guys. Good. Let's move on. Come over here to get a magnitude. It's going to be 3 squared plus 2 squared plus 1 squared. I know that some of you who just connected might be wondering, this is minus 2. So why did I just write plus 2? I've explained that in previous class already. Please check that out. Okay. How to calculate magnitude of a vector. I explain what you shouldn't bother yourself with if you see minus. Magnitude is always positive. This is 9. This is 4. 13. This is 1. 14. Right? So this is square root of 14. 9 plus 4 is 13 plus 1 would give you 14. This 14 does not have any perfect square in it. So we are going to leave it as square root of 14. Similarly, we have magnitude of vector Q is equal to square root. Come to that vector Q. Here we have 1. It's going to be 1 square plus 2 square. And then plus what? 3 square. This, of course, is going to give us 14 still, right? Square root of 14. So we know all the parameters that are required to calculate the value of the angle between these two vectors. Let us now substitute. Let's substitute. Okay, I'm going to continue here. Manage this space here. So our theta is therefore equal to cos inverse P dot Q. The dot product is equal to 2. Then the product of the magnitude of the vectors, magnitude of vector P is root 14. That one of vector Q is also root 14. Theta is equal to cos inverse of 2 all over, from the knowledge of solved, square root of the same number. If you have square root of a number times square root of that same number, is simply equal to that number without square root. So here we have 2 over 14 or 1 over 7. Let us find the cos inverse of these and see. Therefore, the angle between the two vectors, cos inverse, will be equal to, I think I can evaluate that directly. Shift cos inverse. All right, so press a shift, press cos to invoke your cos inverse, then 2 over 14, and this is giving us 81.7867. So let me approximate it. Let me approximate it to 82 degrees. So do you see that the angle between the two vectors is not actually 60 degrees as I had wanted to use. You see, I had to quickly just change that question to explain something better, because if I had used that 60, maybe some one of you at home, you may calculate this dot product now using this dot this, get your answer, and then use this equation again with that 60 degrees. It is expected you should get the same answer, but I know you wouldn't get that same answer. Yes, you wouldn't have gotten the same answer because I used the wrong angle. Like I said, I introduced it, and I didn't take my time to process it before giving. With this 82, if I had told you that, okay, the two vectors P equal to this and Q equal to this have an angle of 82 degrees between them. Yeah. find the dot product of the two vectors. Whether you do this dot this, which gave us 2, or you decide to use this formula straight with the 82 degrees, you'll get approximately the same thing. And we can prove it now. Watch. If I had told you that the angle between them was 82 degrees from beginning, that time I used 60. If it was 82 degrees that I used, could have gotten the same answer if I had used this formula directly. And then another person that would have used the component formula equation 2 directly could have still gotten the same value, which means if I use equation 1 or equation 2 in that case, I will still get the same result. Let's prove it and see. Theta is 82 for these two vectors under this condition. Let us find out now. Magnitude of P, magnitude of Q is square root of 14, square root of 14. So I'll come here and fix root 14, square root of 14 times square root of 14. You know, that is, of course, going to give us, that's going to give us 14, like I said earlier. Then multiply by cos 82 times cos 82. Cos 82. We may not get exactly 2 as expected, but we'll get something approximately equal to 2. And the reason we can't get exactly 2 is because I made an approximation here. Remember, this was 81.7 something I said. Okay, cos 82, let's see what we've got. Good, this is 1.94 something, which is approximately equal to 2 as a whole number. Of course, you must round off this because the angle I used was a whole number, right? So when you do that dot product using equation 1 directly with the given angle, say we got 1.9, which is approximately equal to 2. Exactly what we got when we did direct component multiplication. Good. So we are done with this question, right? So back to what I adjusted earlier. The angle I could have given here, such that if a student now wishes to use this formula, the student will get the same answer as another person that would wish to use equation 2. You know, where you do AX, BX, AY, BY, AZ, BZ, and you add, you'll get the same results. So if I wanted to do that,